first thing we're going to investigate is how does the tire tread wear impact your speedometer. So as your tires wear down, your speedometer is actually going to change. It's kind of like the difference between ground speed and air speed when we were looking at that with vectors. So your speedometer will tell you you're going 70 miles an hour, but you're actually not going to be going that fast. So this is kind of looking at circumference, really, if we think about it. So let's say that we have this tire that has a brand new tire has a diameter of 25.7 inches, but then the tread wears down. So you can see the blue line would be the brand new factory spec tire, and then the red line would be after the tread is worn down. So how is that going to impact your speedometer? Well, first thing you can see down here, obviously this is not the scale, it'd be much longer, but this, the length, the circumference, the distance that you travel per rotation, per revolution, is going to be shortened because you don't have as much tire, so there's not as much diameter. So let's go to the next slide, and we'll kind of investigate this part here. So this is by the way, the tire I'm using is the one for my car. So I actually went outside and measured the diameter for my new tires, which is kind of cool. So new tire has circumference. Our diameter is 25.7 inches, so the circumference would be 25.7 pi inches. So we just add the pi because it's pi times diameter. So what about after a 1/4 inch of tread wear? So if we wear off a 1/4 inch on one side, well, that's also going to wear off a 1/4 inch on the other side. So that'll be a 1/2 inch less of a circumference, right? So every rotation of the tire is going to go a 1/2 inch times pi less of our distance, right? So when the speedometer reads 70 miles an hour with a new tire, we're actually going 70 miles an hour as long as everything's okay. But with the different tread wear, with our shorter circumference, we're not traveling as far for each rotation, so our speed will actually be less. So how do we find out what that actual speed is? Well, it's just going to be a ratio of our new circumference to our old circumference. So if we put this in the calculator, we can put it as 25.2, and I'm going to use the N over D button here. So over 25.7. And then that's going to be our ratio, and that's a percent less of what it shows. So then we just have to multiply that times what the whole thing would be, which would be 70. That's how fast we're going. So that gives us an answer of 68.64 miles per hour. So 68.64 miles per hour. So even though our speedometer says we're going 70 miles an hour, we're actually only going 68.64 miles per hour. So that reduction wasn't that much. Like the overall percentage wasn't that much, but it still does have an effect on it. So we'll look at another example and kind of go extreme. So what about, so when you're actually going 70 miles an hour with worn tires in this example, then what reading does our speedometer give us? So how fast does the speedometer say we're going when we're actually going 70 miles an hour? So with new tires, it's still going to be 70, so that's not going to change. But now what we need to do is our speedometer we would need to go faster than 70, right? Because if 70 on our speedometer is actually this speed, then we would need to go faster. But how much faster? And it's not just the difference between these two. The way we would find it is actually doing the reciprocal of that fraction. So if I arrow up here, I can actually paste this, and I'm just going to switch those two numbers. So we're going to put the bigger one on top now. So this will be an improper fraction, and the smaller one on the bottom, still times 70, and that'll now scale it up because it's larger than 1, right? So how much faster do we need to go? We need to go where our speedometer says we're going 71.8 or 38 miles per hour, and that would be the 8 repeating. Okay, so let's look at another example, kind of going big scale here. So we've got this truck. Now trucks, they have a lot, 18-wheelers have a lot thicker tread because they put a lot more miles on them and they can wear out and without having to replace them as often. So they actually can have a 1/4 or 3/4 of an inch of tread wear would be pretty typical. So, but as the tread wear is wearing down, the speedometer doesn't know that, and so it's still going to give them inaccurate readings. So how far off would it be for them? So let's say that their tires, and I actually looked up the specs on them and everything. So the R22.5, that's actually telling you the I believe the diameter, no, the radius of the tire or of the rim. Sorry, but that's not actually adding the tire as well. So my car, the radius you can see for the rim was 16 inches. All right. I'm pretty sure mine's got 18-inch rims on it. I don't have 20s, but it is a sports model. It's got alloy rims, it's pretty nice. Anyway, so that's going to be 42.5 pi. And if we take away 75 or 3/4 of an inch on both sides, it would be 1.5 inches, which would take it down to 41 pi for our worn tires. So speedometer with new tires is still 70. So again, all we have to do here is our fraction. I'm going to go back up to here because I'm lazy. Copy and paste. And so our full one would be 42.5. And then the smaller one was only 41. I'm just going to delete those. And that's our proper fraction, so it'll be a reduction. So that's going to be 67.53 miles per hour. So even though the speedometer says you're going 70 miles an hour, after 3/4 of an inch of tread wear on this specific tire or whatever, the semi-truck is actually only going 67.53 miles per hour. So maybe that explains possibly why semi-trucks always go really slow and always have to pass them, but that's okay. So what reading should our speedometer be set at when we're going to go 70 miles an hour? So when we're actually going 70, it's going to say we're going faster than that, but we're not because the tires are worn, right? So all I'd have to do is do the reciprocal of the fraction again, which should give us 0.5 and then just 41 on the bottom. Let's try that again. Okay, so it's an improper fraction, so it's going to be bigger, which is 72.56. So if we knew what the circumference of our tire was, how much the tire's tread has worn, then we could adjust the speedometer for this. Maybe in the future, I wouldn't be surprised if some Mercedes E-Class, they actually adjust the speedometer as the tires wear because they have tire pressure monitoring systems and stuff like that. And so a lot of things you wouldn't think that they would be able to put in there, but maybe if they had a way to monitor how much the tires have worn down and the tread depth, then they could actually do the math like we see here pretty easily to be able to adjust the speedometer, which is probably done electronically anyway. So it would be really, really easy ratio to be able to adjust it so that your speedometer is always accurate, regardless if you have new tires or worn tires. Kind of cool. And as we're seeing here, it's not making a huge difference, about 3 miles per hour in the worst case scenario, even with, big trucks. But if we're going faster, that, percentage is going to really start to show up. So this is where it gets fun. So let's say you didn't want to get any 20s, right? You got 30-inch aftermarket tires. So some big old massive tires on your car, right? So here you have your factory tire in blue, the worn tire in red, but now we got a 30-inch diameter because we put some crazy aftermarket tires that were not designed for our vehicles by the OEM, right? So it's not original equipment manufacturer or anything like that. So how would that change it? So now we're actually going a further distance each rotation of the tire because the diameter is so much larger. So we're going to be speeding even though our speedometer doesn't say that we're going that fast because each rotation is now taking us a much further distance. So on this one, the circumference, of course, that's the factory. Now it would be 30 pi, right? So all we have to do is take the fraction. So I'll just type it in again. So we have 30 divided by 25.7. We're going to multiply it. We'll do 70 miles an hour still. So when our speedometer says we're going 70, we're actually going well over 10 over the speed limit. And that's probably why we get pulled over so much. So yeah, this is actually a public service announcement. If you spec your tires, typically if you buy rims that are larger, they reduce the actual the thickness of the tire, which makes the ride a little rougher as well. But they try to keep the overall diameter the same, and the reason they do that is because of this whole thing with the speedometer. But if you get some really, really large tires that were not made for your vehicle, maybe more likely if you probably on a pickup truck, right? So if you put some big off-road tires on there and you don't adjust the speedometer, I don't know quite how they do that, but not a mechanic, but you will have issues, right? So this could actually happen. So someone in a really big truck that used to have really small tires and now they put massive tires on it, their speedometer might say they're going 70 when they're actually going much faster than that. This is a bit of an extreme example, but you can see how you can get in trouble with this. So I will post this video separate. I'll see you for part 2, where we will go into talk about China and time zones.